Alright, so in this video we're talking about simplifying rational expressions, but this time with an added twist. We're going to subtract two rational expressions from each other and then simplify. And then we're also going to go back and do another problem where we add two rational expressions together and simplify. So this video kind of builds off what we did on the last video where we simplified rational expressions by factoring. So that's going to be one of our steps. We're just adding a few more steps before that. So, anytime you want to add or subtract rational expressions, what you need to do is to first find what's called a common denominator. And to find a common denominator is just as simple as multiplying by three different ways. So the first way we're going to multiply is just multiply our bottoms together. X plus 2 and x minus 2. Then we're going to multiply from the bottom to the top left. X minus 2 times 10. And then we're going to multiply from the bottom to the top right. X plus 2 times 6. Okay, so when we do these three multiplications, it's going to create one single fraction, and that's the very first thing we need. So again, we multiply the bottoms, x plus 2 times x minus 2. And I'm going to leave that alone because the bottom is staggered as nice as it can be. Now I'm going to multiply the bottom and the top left, so I have 10 times x minus 2. And then go back and multiply the bottom times the top right. 6 times x plus 2. In our original problem, in between these two fractions, I had a negative or a minus. So to connect my two terms in my numerator, I want to put that negative or minus, however you want to call it. Now, this is pretty easy. We just want to start simplifying the numerator as much as we can. Again, the denominator is going to, for this particular problem, is going to be left alone because it's factored as nice as it possibly can be. So my numerator, I have two sets of distributive property. Distributive property should be pretty easy. Okay, so we have 10x minus 20, negative 6x minus 12. Okay, so now our bottom, our denominator stays absolutely the same. X plus 2, x minus 2, and what we want to do is start combining like terms in our numerator to start simplifying as much as we possibly can. So again, the bottom stays the same. And our numerator, 10x minus 6x is 4x. Negative 20 minus 12 is negative 32. Well, this isn't a difference of two squares, so the only thing left that it possibly could be is a GCF problem. What I'm going to do is look for the biggest thing that both of these terms in my numerator have in common, and that would be 4. So when I pull out a 4 out of my numerator, I need to ask myself, 4 times what will give me 4x? Well, that's pretty easy. It's x. And 4 times what will give me negative 32? Also easy. Negative 8. My bottom still stays the same. X plus 2, x minus 2. And unfortunately, nothing else will factor here, so I cannot cancel anything out. Remember, to cancel, you have to have identical pieces on top and bottom. Nothing cancels, that's okay. So what we've done now is we've subtracted the two rational expressions that we started with in our original problem, and we simplified as far as we can go. That's it for this example. In our next example, what we're going to do is pretty much do the exact same thing, but instead add two rational expressions together. So again, when you're subtracting or adding rational expressions, the very first thing you want to do is to find a common denominator. But first, before I do that for this particular problem, I'm going to go ahead and factor wherever I can. Just get everything in its lowest possible factor form. That may save me some work in the end, or it might not. It's just a personal preference. If you like this step, then go with it. If not, go ahead and find your common denominator and proceed from there. So again, I want to go ahead and factor out wherever I can. So 1 plus 2x, there's no GCF there, and there's nothing else I can do. It's going to stay the same. In the bottom of my first fraction, however, 3x minus 3 has a GCF of 3, so I can pull out a 3. So I have 1 plus 2x still on top of my original fraction. Pull out a 3 on the bottom, x minus 1. Okay, and we said plus in the middle. In my numerator, for my second fraction, I have 5 minus x. Can't do anything there, so it's going to stay 5 minus x. And in my denominator of my second fraction, I have x squared minus 5x plus 4. Well, that's a trinomial. Trinomials we typically have factored in the past by using the bottoms-up method. So if we use the bottom-up method here, we would see that this factors into x minus 1 and x minus 4. Again, if you need help with the bottoms-up method, I would refer you to those videos, but since we've already discussed that at length, I don't want to waste your time. All right, so now what we need to do is start finding our common denominator. So again, remember, it's just 3 multiplications. Once we finish with these 3 multiplications, we're going to have a common denominator, and we're going to have one single fraction. So remember, we multiply across the bottom, we multiply from the bottom to the top left, and then finally our last step will be multiplying from the bottom to the top right. So let's go ahead and take care of that bottom step first. Alright, so on the bottom of our new fraction, our new single fraction, we'll have 3 times x minus 1 times x minus 1 times x minus 4. Okay, again, the bottom just stays exactly the way it is. I don't want to do anything here because it is completely factored. Now, multiplying from the bottom to the top left, I have 1 plus 2x times x minus 1 times x minus 4. And then multiplying from the bottom to the top right, I have 3 times x minus 1 times 5 minus x. We start off with plus in the middle of our 2 fractions, so to connect our terms in the numerator of our new single fraction, I also need to put my plus there. Alright, so now I need to start combining like terms along the top in my numerator. Okay, but before I can do that, I actually need to multiply out these polynomial expressions using FOIL or the box. I like to use the box. This is going to be a little bit of scratch work, so if you want to fast forward and see the result, that's fine. Or if you want to follow along and practice, that's also good. So I'm going to take care of this piece in black and this piece in blue. And again, this is just scratch work, so if you need to skip a step, then do that. So what I'm going to do is 1 plus 2x times x minus 1. And I use the box. Some people like FOIL better. That's just whatever is your preference. And this is strictly scratch work. So x, 2x squared, negative 1, negative 2x. Combine like terms wherever we can. So we have 2x squared minus x minus 1. And that's still going to be multiplied by x minus 4. I want to have to do the box again because I have 3 sets of polynomial expressions. So that means I'm going to need 2 boxes. This time I need 6 squares in my box. So 2x squared minus x minus 1, x minus 4 here. So I end up with 2x cubed minus x squared minus x. We have negative 8x squared minus, or positive 4x plus 4. So this piece of my numerator in black is just going to be 2x cubed minus 9x squared plus 3x plus 4. Okay? Now I'm going to do my scratch work for the second piece of my numerator. I have 3 times x minus 1 times 5 minus x. I'm going to do the x minus 1 times 5 minus x first. So I have 5x minus 5 minus x squared plus x. Okay, and I want to combine like terms. So I have minus x squared plus 6x minus 5. Now, this 3 that was on the outside, I'm just going to multiply this trinomial by 3. So it's kind of like distributive property again. So we have negative 3x squared plus 18x minus 15. Okay, so now using these 2 pieces, I'm ready to write my new numerator. I'm going to do that in green because everything's good to go now. So we have 2x cubed minus 9x squared plus 3x plus 4 minus 3x squared plus 18x minus 15. And our denominator of our fraction just stayed the same. I didn't touch that. It's just 3 times x minus 1 times x minus 1 times x minus 4. Okay, Okay, now before I start factoring and reducing, I need to cancel out any terms that I possibly can, or at least combine like terms. So in my numerator, I still have 2x cubed. Negative 9x squared and negative 3x squared is negative 12x squared. 3x and 18x is 21x. And then 4 and negative 15 is negative 11. Okay? And my bottom stays the same. Okay? And so now what I can do is, in my numerator, I can try to factor that by grouping. However, I'm kind of concerned about this negative 11. Negative 11 is prime, so it's probably not going to factor, but I'm going to try anyways, just doing some scratch work. Remember, we have 4 terms in our numerator, so the only factoring option we have is by grouping. So you kind of see how all these videos are tying in together. Remember, when you factor by grouping, you draw a box with the same number of squares as you have terms, and you punch your pieces on the inside. So 2x cubed minus 12x squared, 21x minus 11. Okay, so again, what I'm looking for is GCF of each row and each column. So in the top row, I have 2x squared. And at the bottom, the only thing, let's see, the only thing I'm going to have is a 1. That doesn't really help at all. And then in my left column, my GCF is going to be an x. So automatically I can already see that this is not going to factor because there's nothing I can do to get to this 21x. So like I thought originally, my numerator does not factor. So my final answer, adding these two rational expressions together and simplifying as much as possible, is this. Sometimes things will cancel out and you'll get a nice reduction. Sometimes they won't. It'll stay really messy like this. Either way, again, we started by first finding common denominator. And that's the most important thing you can take away from this video. Thanks a lot.